So here we're given a simple circuit, 2 voltage sources, and we are asked to calculate the value of IL, which that's this current here going through RL. And they ask us to do this using superposition. So let's see what that would entail. So when we do superposition, we consider the contribution from one source at a time. So in this case, we're going to consider first this source here. So when we do that, any other voltage source we're going to short out. So it's like we short this out here, so it's not there. So now when we do that, we notice in our circuit, we could actually redraw this in such a way, and let's do that real quick. And so it's like this isn't here, and so then we short this out. So when we do that, we can calculate the current IL from this source. Before we can do that, though, we need to know what the total current is. And before we can do that, we need to know what total resistance is. So looking in to this direction, we see then that our R total, we'll call this R total 1, that's going to be equal to R1 plus R2 in parallel with RL. And so if we plug the values in for that, that's going to be 3 plus 12 times 6 over 12 plus 6. And when we calculate all that out, we should get 7 ohms. So then our I total, which we'll call this I total here, flowing from our source, I total, again we'll call this number 1, that's going to be equal to our voltage over our total resistance, and so that's going to be 42 over 7, or 6 amps. And so then we see then that IL would just be the current division, it's a current divider. And so when we do that, IL, that's going to equal to, IL is going to equal to I total times the resistance through what we call the other leg, not interest leg, over R total. So in this case, we're interested in the current here, so the other leg would be this one. So it'd be R2, so that's going to be 12, that's going to be 6 times 12 over 6 plus 12. And so when we calculate that out, we should get 4 amps. So that's the value of IL from the 42 volt source. So now let's start over and consider the other source. So in this case, we're considering this source here. So when we do that, just as before, we short this circuit out, or this source out here. So we can do that real quick. And when we do, it's like this line's here, like it never happened. So now we see that we should have a total current coming this way from our source. So we need to calculate what that is. So first we look at what the resistance is. And so just as before, our total number 2, that's going to be equal to R2 plus R1 in parallel with RL. So in this case, that's 12 plus 3 times 6 over 3 plus 6. And so when we calculate that out, that comes to 14 ohms. So again, we calculate our total. So I total 2. Again, that's going to be V over R total 2. And so in this case, it's going to be 21 over 14. And so that comes to 1.5 amps. 1.5 amps. Now, notice our voltage source is what some might call upside down or backwards. So we're going to need to put a negative sign there to show that that's in the opposite direction. But then again, our IL, again, is going to be using current division. So this is the branch we're interested in, so that means this would be the branch that we would call other. So in this case, it's going to be the total current, which is negative 1.5 amps, and that's going to be times 3, the other resistor, over the total, which is 3 plus 6. And so in this case, that's going to come out to a negative 0.5 amps. So now we see then that we have our contribution of IL from the left-hand source, our E1, and then we have our current contribution from the right-hand source, or E2. So therefore, IL total would be, let's say this is IL1 and IL2. It's going to be IL1 plus IL2. So in this case, that's going to be 4 minus 0.5 amps. And so the total is 3.5 amps. So this is the value of IL, taking into account both sources in this circuit.